When dealing with files and streams, it is important to know the keywords that are used in file manipulation. The first being OF stream or off stream, and this data type represents the output file stream and is also used to create and to write information to files. Secondly, we have if stream, and this data type represents the input file stream and is used to read information from files. F stream represents just the general file stream and it has the capabilities of both OF stream and if stream. So we have iOS and we have our scope resolution operator and app. And app is here in this case is the short for append to the file. Then we have the ATE, which sets the current position to the end of the file. And then we have trunc, which is short for truncate, and this deletes all the contents in the file. Now that we've looked at some of the classes that perform output and input of characters to files, let us now look at some basic examples. So before we can do any file manipulation, we need to include our file stream library. So this is fstream. And now we can declare an object or instantiate an object for offstream. So let us say offstream, and I'm just going to create an object called my file. And now that I have my file object, I can say my file dot, and it gives us several operations that we can perform. So what I'm going to do is open a file, and of course we will need a file name. So I'm going to use example.txt, and this will create a file called example.txt for us. Next, I'm going to say my file, and in this instance I'll be writing to this file. So writing contents to the file. Let's throw a new line. And then we simply close the stream. So my file.close. And once we run this program, it will create a file for us and put the contents inside the file. So let us run this. And it executed successfully. So to find the file that was created, you can right click on your project name in Visual Studio and then go to Open Folder in File Explorer. And this will open up your directory. So these are all the files that we have been working with. And here you can see it has created a file, a txt file, text document called example. And we open it and we see that it has written our message here to the file. Okay, so that's a really basic example of how to create a file and write some content to it using offstream. So in an if stream and offstream class object, iOS in and iOS out are automatically assumed. Right, so this deals with the input and output of a file. So these are automatically. Right. So if we wanted to make a modification to this file, so currently, if we say we wanted to change or add some content to our file, let us say this is a new line. Okay, so let us run our program now and see what happens. All right, so if we go to our directory and open our file, you'll see that it has completely overwritten what was there before. So in order for this not to happen, we have to also include iOS : append. All right, so this is short for append. And once this is done, we can change this and say have third another line. And when we run our file, our program, and open our file, we'll see that it is now appending that content to our file instead of overwriting that content. So that is the use of the append feature. So if we wanted to, add a separate line here, and say this is also a new line, and you'll see that it will just continue to append, right? So it now appended both lines that we had there. Cool. So we're going to take a look at the concept of defensive programming here shortly. And when you're dealing with files and streams, it is always important to check whether or not the file is in an open or closed state before doing any operations on that file. And one way that we can do this is by using the isOpen function. So this function returns a Boolean value of true or false, and it will be true in the case that the stream object is associated with an open file, or false if it is otherwise. So the way that we can implement this in our program, okay, so we have created our object here, and since we already, okay, so let me completely change this example. So I'm going to use my file again. So I'm going to recreate OF stream my file. And in this case, let me use the constructor to initialize example, or let's say new file .txt. So we can do a check. So we can say if my file is open. So this will return a true or false. So if it is open, we want to say my file, and we'll add some content to it. And we'll say this is a second line of content. And we need to remember to put our new line at the end of these statements. Otherwise, everything will be on the same line. And of course, we can include our iOS append. Sorry, colon. Right, so if the file is open, we want to add these lines to it. Else, we can give the user, give them a nice little error statement. So we can say unable to open file. So it's always good to perform that check when dealing with files, right? So this is what is known as defensive programming. So let us run our program. And it has run successfully. So let us check our directory. All right, so here we have our new file, and it is printing exactly what we want to print to it. So now that we see that this works, if we wanted to delete the contents of the file, of course we can call myfile.chunk, and of course you know that this will destroy the contents. So now that you see how we write to a file, it's time to take a look at how you can read from that very same file. So in order to read from a file, first let us create a variable, and let's just call it line because it's going to read each line in that file. And let's make some modifications to our program. So now instead of off stream, we're using if stream. So let's change this. And let's remove the append because we will not be appending anything. Right, so we're checking now if the file is open. We will need to use a loop to read all the lines from that file. So let's just say loop, and in this case we'll be using a while loop to read each line. So we can say while, and we're going to use a function called getLine. And we're going to pass in the name of our file and also our line variable, string variable. Now we have an error here because we need to include, let's see here, we need to add a directive to include string to our program. So if you're using Visual Studio, you can just go ahead and click on this and it would automatically add that header file for you. So we need it to be able to use the getLine function. So it's going to get each line. So while it is getting each line, let us print. So we can say cout line. And let's just throw a new line in here. And we're not going to use an else statement. So let's remove that. And we need our myfile.close inside our if statement. So here's where our if statement starts. So let me press enter just so it's a little bit more readable. So sometimes you can expand your program out like this just for readability purposes. So we need the myfile.close to be within our if statement. So let us just cut it from here and we can paste it right here. Okay. So our else is going to be outside the if statement. So if it is not able to do all of that, then we can say else cout unable to open our file. So let us run this and then see what happens. Right, so it is reading the contents of new file, and if we want to double check the contents of new file, just to ensure that it is doing what it's supposed to do. You can see that it is reading that correctly. And let's try reading from example. Right, so if you want to double check again, you can see what's inside of example. And we see that it is reading exactly what's inside the file. So I've gone ahead and added some sample stock inventory information to my example.txt, and let's run it. So let's see what comes up. Control F5. All right, so if we maximize this, it's not much. It's just a couple of headers and some information. So you can see that if, whatever is stored inside your file, however it is formatted, once you read the contents of that file using if stream, it will just print it out using this while loop. So that's it for if stream and file reading. Now, defensive programming is a very important concept as it relates to software development. We're going to be looking at the topic of exception handling, and exceptions really provide a way to react to exceptional circumstances while you're developing your program, like runtime errors and so forth. And this is done by specifying to the program that you want to transfer control to special functions called handlers. And in C++, we use 3 particular keywords to perform exception handling. So the try block identifies a block of code for which a particular exception will be activated. And it is followed by 1 or more catch blocks. Now, in the catch blocks, this specifies to the program where you want to handle the problem. And as the keyword suggests, it's like, catching an exception. So a program throws an exception when a problem shows up, and this can also be done using a throw keyword. So the try block identifies the block of code for which an exception may occur. The catch keyword catches that exception, and you use the throw keyword to throw a proper error message when that problem shows up. For our example, let us consider an arithmetic operation where we try to divide by 0. Now, if we use our calculator and let's say we try to do 4 divided by 0, you'll see the error message here, cannot divide by 0. Okay, so if we try that in our program and we try to print Cout, let's say 4 divided by 0, and we try to run it, of course we are going to get errors, right? And it's going to tell us we're trying to divide or do modulus by 0 in line 14 of our program. So we see here that that is not a possible operation. So if we were to declare a function, and let's give it a return type of double, and let's call it division, and let's say we pass 2 parameters, int a, int b. So inside this function body, we can say if b is equal to 0, which is the number that we're going to use to divide, then we can actually throw an exception. And my throw message would be division by 0 not allowed. And if they're actually dividing by an actual number, we want to return a divided by b. All right, so a simple function that does a check. If our second variable b is equal to 0, we're going to throw an exception. Otherwise, we are going to return a divided by b. So in our main program, let us define 2 variables. Let's say int num1 equals 50, and num2 equals 0. And let's say we do cout, and we call our division function, and we enter num1 as our first variable and num2, and we try to run it. Okay, so that didn't run. And if you want, we can try to run it again so you can see the nasty the nasty debug error that has popped up in our program. Now, when we're building a program or any software, you definitely do not want the user experience to be one like this, where they try to perform an operation and the program ends up, blowing up, or they get these nasty runtime or debug errors. So you have to account for these when you are developing and make sure you have the correct try-catch statements in your program. So to clean this up, let me actually create another variable called num3. And let me just initialize this to 0. Now we're going to implement our try-catch block. So first we start with try, and then we say z is equal to the division of n1 by n2, and then cout z value, and let's throw an end line here. So if we do this, this should be n3. I'm actually thinking of x, y, and z, so I'm using n3 in this example. So let's keep that. Okay. So at this point, we need a catch block now that we have our try block. And in order to catch this error and display it so that our user can see that our throw message up here, we have to define a constant, and it's const char, and we are going to point to the message. So we're creating a variable. So this is our variable. Message here is our variable, and it's going to store this throw message up here. And we're just defining a char that is a pointer to this message. And of course, a constant variable the value does not ever change. So that's what we're doing here. And now we need the body of our catch statement. And we can use C ER, and this is a file stream object, and this will actually display our message. Okay, so now if we run our program, we'll see that we get our throw message, right? So using try catch, you're able to chain as many catch statements as you need. So you could have several different catch statements, and these could be different, messages. They could deal with strings or, numerals and different types of things. So you can chain as many catch statements as you need. But this is basically the example. So to recap quickly, we have a division function, and we are checking to ensure that we protect against a user trying to divide by 0. So let's say we were actually building a calculator. So like I showed you, when we try to divide by 0 in our calculator, it gives us an error message, right? Calculator program doesn't blow up and just, stop working. So that's the importance of having your defensive programming and using your try, catch, and throw keywords. So here we're checking to see if the second argument or parameter is equal to 0. And if it is, we want to throw a message call and tell our user that division by 0 is not allowed. Okay, and then if the second variable is not 0, then we're going to return a divided by b. And down here in our program, we just created some variables. So I mean, we could make the program interactive. We could actually ask a user to enter these values. So instead of having the values already pre-entered, let me remove that. And then we can prompt the user and say cout enter number to be, let's just say to be divided. I'm not going to get too cute with our prompt messages right now. So, and right, so let us just put a colon here. Then we're going to do cin, whatever that first input is will go into N1. And then we do the same thing for the second number. So we're going to enter a second number. And let me in fact throw this one into a new line. Then let's do cin to N2. All right, so now we have a prompt so that our user can actually enter a number. So let's run this. So we want to enter as 8, and second number, let's say 4. Right, so the answer would be 2. And of course, if you want the user if you want a better message for the user, then that's fine. But we see we get our answer. So if we try to divide, let's say 9, and enter a 0, we're going to see division by 0 not allowed. So there you have it, your basic infrastructure to help you with your defensive programming.